Hi guys. Afternoon everybody. Just let me know if you guys can hear me before we start, please. All right, great. All right, so let's get started here. All right. All right. So first things first, guys. So my new online classes, right? Now this is generally for students who are starting the syllabus from scratch. These sessions will begin in August. So I normally start 1 month before the school term begins, right? And these are the four subjects that I personally teach, and that is maths, maths, chemistry, and physics, right? Um, but today's session here, we're going to focus our attention on maths paper 2, right? I know you guys have the exam tomorrow, right? So we're going to go through a sample paper, right? One of my sample papers here. So we have a question here. The first question here is based on remainder and factor theorem, right? So let's have a look at this here. Given that f of x, right, is equal to ax cubed plus 3x squared minus 8x plus 3. So that's a function. It's a cubic function because we know we have an x cube here. Now, in the function here, we have a, right? We have a here, and we need to figure out what is a, but we are given that x minus 1 is a factor, right? So when it comes to the factor theorem, right, this x minus 1 here, if we put that equal to 0, right, you're going to get x is equal to 1. Now, when they tell you something is a factor, it means that in this case here, f of 1, if I plug 1 into that function, right, I'm going to get 0 as my answer. Because if something is a factor, it means that when we divide it by that factor, we are not going to get a remainder, right? So this part 1 here, all we're going to do, so the function is ax cubed plus 3x squared. So the function here is ax cubed plus how much? 3x squared minus 8x all right, plus 3, right? And we know that f of 1 has to be equal to 0, right? So if you want to solve for a, all you need to do is to substitute 1 into the function. So this is going to be a by 1 cubed, right, plus 3 by 1 squared, right, minus 8 by 1 plus 3, and that's equal to 0, right? So whenever you're doing a question like this, try to do it bit by bit. So 1 cube is 1, so 1 by a is going to give us a, plus 1 squared is 1, 1 by 3 is going to give us 3, and minus 8 plus 3 is equal to 0, right? So therefore a, now 3 minus 8 is going to give you minus 5, minus 5 plus 3 is going to give you minus 2. So therefore a minus 2 is equal to 0, and therefore a is equal to 2, right? Now typically this is just a 2-mark question, right? So we have to find an unknown coefficient given the fact that we know that this is a factor, right? So that's the answer for part 1, right? A part 1. Part 2 now, if you are asked to solve an equation like this, right? This is a cubic function that you're trying to solve here, right? Whenever you solve a cubic function, what's supposed to happen is this. You're going to end up with 3 different brackets, right? So if you factorize a cubic function, you're going to get 3 brackets, right? Just like when we factorize a quadratic, we normally get 2 brackets. In the case of a cubic function, you're going to get 3 brackets, right? But the thing is, we only know one of them so far. We know that x minus 1 is a factor. So what we need to do, we need to figure out what the 2 other factors are. So in order to do that, we have to perform what we call a long division, right? So we have a is 2, so it's 2x cubed plus 3x squared minus 8x, right, plus 3, right? So here's what we're going to do here, right? You already know one of the factors. One of the factors is x minus 1. So we're going to perform what we call a long division here, right? So to do this long division here, right, this is going to be 2x squared. So 2x squared by x minus 1 will give me 2x cubed minus 2x squared. Right? Next step in this process is to perform a subtraction. 2x cubed minus 2x cubed, that disappears. And we have 3x squared minus 2x squared. That's the same as adding. So this is going to be 5x squared. Next step in the process is that we have to bring down this minus 8 here. So this is minus 8x, right? Then on top here now, on the quotient here, this is going to be plus 5x, right? So we need to take that 5x now and multiply by x minus 1. So this is going to be 5x squared minus 5x, right? So we're going to subtract again. Minus 8x minus 8x is going to give us minus 3x, right? And then we need to bring down this plus 3 here. So this is minus 3x plus 3. So if you want to get minus 3x, this has to be a minus 3. So minus 3 by x minus 1 will give me minus 3x plus 3. And when I subtract this, I'm going to get 0 and 0, right? So in this case here, right, in this case here, we have our quotient. That's up here. So this here is your quotient. Right? Now, what we're going to do, we're going to have to factorize that quadratic to get the other two factors. Right? Let me just get a blank slide here. Hold on. Now, in terms of writing out your answer, the question says, right, look at what the question says. They said solve this equation, f of x is equal to 0. So what you're going to do, you're going to say, all right, well, f of x is equal to 0, right? And based on what the long division here, we can say that the quotient, right, the quotient multiplied by this factor here is actually equal to f of x. So you're going to write this as x minus 1, right, multiplied by the quadratic we got as a quotient, which is 2x squared plus 5x minus 3. Right, and that is equal to 0, right? So all we need to do now is to factorize this here, right? So this is going to be 2x, right? 1 and 3 here, and you want to get plus 5x, so this is going to be minus here and a plus here. That making sense? Minus 3, 2 to the 6. Yeah, that makes sense, right? So your solutions, right? So we're going to put each one of the bracket equal to 0. So x minus 1 is 0. Therefore, x is equal to 1. Next thing we're going to put is 2x minus 1 is equal to 0. So 2x is equal to 1. And therefore, x is equal to a half, right? So we have two solutions already. And the last solution will be x plus 3 is equal to 0. And therefore, x is equal to minus 3, right? So this is how you solve a cubic function, right? That's how you solve a cubic function, right? Right? So the solutions are 1, a half, and minus 3, right? So that's part A, right? Part B here now, we have a log question to solve, right? We have a log question to solve. Just for your knowledge, right? There are some log rules that you all need to know and you need to remember. And those rules are log to base b of a, right? Plus log to base b of b, right? If you're adding logs and you have a common base, then you can combine it to be a multiplied by b, right? So that's one of the rules regarding logs. If we subtract, right, minus log to base b of b, then what we do for this one here, we're going to divide, right? So this is your second rule for logs that you need to know. And there's also a power rule that we need to know as well. So that is, if I have log to base b of a to the power n, right, and I want to rearrange this, I can bring that n to the front and it'll be log to base b a to the power n, right? So you all need to know that, right? you also have to be able to switch between exponent form and log form. So if you have something like log to base b of, let's say, e, right, and that is equal to, let's say, x, right, you have to be able to take that log expression and write it in an exponent format. What we do, we say the base raised to the power x is equal to e. So you all have to be able to switch between those two, right, under exam conditions. All right. So let's have a look at the log question that I have here. All right, so the log question, let me take a copy of this, yes? Hold on, instead of me writing this out. All right, so this is a question here, right? This is a question here. So we have log to base 10, right? 1 minus 3x minus 2 log to base 10 of x is equal to 1 minus log to base 10 of 2 minus 5x, right? Now, what's going to happen here, you're going to realize I have log to base 10 here, I have log to base 10 here, I have log to base 10 here, right? But you have a 1 here. What I need to do, I need to replace this as log to base 10 of something, right? So 1, right, is actually equivalent to log to base 10 of 10, right? So what I'm going to do, I'm going to replace that 1 as log to base 10 of 10. So here's what you're going to do on the left side. You're going to write this as log to base 10 of 1 minus 3x, right? This 2 that we have here, we're going to write this as log to base 10 of x squared, all right, is equal to, and I'm going to replace the 1 as log to base 10 of 10, right, minus log to base 10 of 2 minus 5x, right, 2 minus 5x. Now, what we're going to do, we're going to apply our rules for logs here, right? So if you're subtracting on the left side, it's going to be 1 minus 3x all over x squared, right, is equal to 10 over 2 minus 5x, right? So we have an equation here that we're trying to solve, and clearly it looks like a quadratic. So we're going to cross multiply. So we're going to say this by this is equal to this by this, right? So what I'm going to get here is 10x squared, right, is equal to 1 minus 3x, right, by 2 minus 5x, right? So therefore 10x squared is equal to, now we need to remove this bracket here, and whenever you have to remove a bracket, take your time, right, and do it in a systematic way. So you're going to take this term and multiply by this, right? You're going to take this term and multiply by this. We're also going to take this by this, and then this by this, right? So it's a systematic multiplication we're doing here, right? So in this case here, 1 by 2 is going to give me 2. 1 by minus 5x is going to give me minus 5x, right? Then I have minus 3x by 2, so that's minus 6x, right? And then we have minus 3x by minus 5x, which is plus 15x, right? 15x squared. So what I can do, I can carry everything to the right-hand side, right? Or the left-hand side, doesn't matter. So you're going to end up with, this will be 2 minus 5x minus 6x is going to give you minus 11x, right? And then 15x squared minus 10x squared is going to give me 5x squared, right? Could you all factorize this for me if it can? 5x squared minus 11x plus 2. Could that be factorized? Could you all factorize this for me? Just let me know if it can factorize, right? Right, so if it factorizes, let me know what you're getting, right? I need a blank slide again, yes? Hold on. Right, 5x squared minus 11x plus 2, let's see. Right, let's see if that can factorize. So 5x here. Right, so let's say 1 and 2. So you want to get 5x squared, you want to get plus 2. So if you put a minus sign here and you put a minus sign here, will that work? 5x squared minus 1 minus, yeah, that looking like it'll work, right? So therefore 5x minus 1 is equal to 0, right? And therefore 5x is equal to 1, and therefore x is equal to 1 over 5, right? Or we can get x minus 2 is equal to 0, and therefore x is equal to 2, right? Now here's my question to you guys, right? Now we factorize it here, right? But when you all doing a log question, there's something you need to pay attention to, right? Even though we got 1/5 and we got 2, we have to double check to make sure that actually is a solution, right? That's something you should always check, especially when it comes to logs, right? Now check this. I know this is something that people generally don't pay attention to, but this is the original equation here, right? That's the equation. Now what we need to do, we need to make sure that if I plug, let's say if I plug 2 into this equation here, you're going to end up with 1 minus 6, which is going to be minus 5. You cannot find the log of a negative number. So therefore, this here is not a solution, right? This is not a solution. So whenever you have a log question, you should always double check to make sure that the answer actually works, right? If I were to put 1/5 there, right, this will work out fine. If I put 1/5 here, that'll work out fine. And if I put 1/5 here, that'll also work out fine. So this here is actually the answer, right? So keep that in mind. When you work out a log problem, you need to double check the answer to see if it actually works, right? So this here is your answer. The answer is actually 1/5, right? I know some of you are watching and thinking the first time you see this. Alright, now I can't look at every single thing in the chat, right? So whatever glimpse I might respond, but I can't see every single thing. A lot of questions coming in here. Alright, this is part C here, alright, and we want to find the range of values of x for which, so we have a quadratic inequality here. That is 2x squared plus x minus 6. 2x squared plus x minus 6. Right, is greater than or equal to 0, right? So when you have to solve a quadratic inequality, the first thing we need to do is to actually factorize this thing here, right? So let's say right, let's see, 3 by 2. I put a 3 here and a 2 here, right? Let's see if that works out. 2x squared plus minus. Does that work out here? 2x by x will give me 2x squared, minus 3 by 2 is minus 2, and 2 2s are 4x. Yeah, that's looking like it'll work out here, right? Now, when you have a quadratic inequality, work out your two brackets, right? Work out your two brackets here. What that's going to do, that's going to tell me that 2x minus 3 is equal to 0, 2x is equal to 3, and x is equal to 3 over 2. Right? The next solution here is x plus 2 is equal to 0, and therefore x is equal to minus 2. Now here's the thing. We want to solve the quadratic inequality, right? You're not going to get fixed values. Like 3 over 2 and minus 2, that's not the answer, right? It's an inequality here that you're trying to solve, right? So what I would do, I would normally tell students, look at the coefficient of x squared. It's positive, so you know exactly how the graph is supposed to look. It's supposed to look like this, right? A is positive, so it looks like that. It has a minimum point, right? The next thing I tell my students to do is to draw the x-axis, right? That's your x-axis here. What we're going to do, we're going to label these 2 points, right? Now we're labeling these 2 points with the 2 numbers that we just got. We got negative 2 and 3 over 2. So based on the number line here, this is negative 2 and this here is going to be 3 over 2. Now, because the inequality sign is a greater than sign, what you are asking yourself, is my graph, or where is my graph above the x-axis? That is what this inequality is asking us here. So what you're going to do, you're going to realize, wait a minute, here is where the graph is above, and here is where the graph is above. So what that tells me is that any value of x greater than 3 over 2, and any value of x less than minus 2. So your answer, right, your answer is going to be x is less than minus 2, right? Or x is greater than or equal to, less than or equal to, right? 3 over 2, right? So that's my solution. Now, you can write your answer in the form of set notation if you want, or if you just write it like this, you'll still get a mark, right? Right, so that's that question there, right? Let's see what else we have. We're still on question 1, by the way. Right, now part D now, that's another one that students generally hate to do, right? We have a quadratic, and they're telling us that the roots are alpha and beta, right? Without calculating the roots, so we're not calculating what is alpha and what is beta. We want to work out what is alpha squared plus beta squared, right? It's a typical examination question, right? So I just want to copy the question here so I have it on one page, right? Right, so this question is based on sum and product of a quadratic, right? So this is what the question is here. So we have a quadratic here, right? So if I were you, I'll write down the quadratic. So 2x squared minus 3x minus 5 is equal to 0, right? That's a quadratic. What we're going to do, we're going to compare that with the general form, which is ax squared plus bx plus c is equal to 0, right? What that allows us to do is to figure out what is a. So a is equal to 2, right? B is equal to minus 3, and c is equal to minus 5, right? Now, the question says that the roots are alpha and beta. Now, if you know the roots, you can work out what is the sum of the roots, right? So the sum of the roots for a quadratic is given by minus b over a. So in this case here, it is going to be minus 3 all over a, which is 2. So therefore, this is going to be 3 over 2, right? So just like that, I've worked out the sum of the roots. The product of the roots now, that's alpha times beta, right? That is actually equal to c over a, right? So in this case here, it is going to be, what is c? C is minus 5. So it's going to be minus 5 all over 2. So that's your product. The product is going to be minus 5 over 2, right? Now the question wants us to work out alpha squared plus beta squared. So alpha squared plus beta squared, right, is actually equal to, right? So I would have given my class this formula. You need to know this, right? That's the same as saying alpha plus beta squared minus 2 alpha beta. So this is something you should have learned off, right? Because this is a common question that they do bring, right? So if you want to find the alpha squared plus beta squared, I'm going to use this identity here. So the sum was 3 over 2. So this is 3 over 2 squared, right, minus 2 alpha beta. So that's going to be 2 by alpha beta, which is minus 5 sm. Right, so that's 2 multiplied by minus 5 over 2. Right, so this is going to be 9 over 4, right, plus 5. Right, so this is 9 over 4 plus 5. Right, so this here is 29 over 4. Right, you can just double check my calculation if you want to, right? Right, somebody's asking what you would do if you wanted to find the roots. Well, if you want to find the roots, you have several options. If you can factorize, you factorize it. If you can complete the square, you complete the square, or you can use the formula if you need to, right? Right, see some people asking what paper is this. This is my sample paper, right? One of my sample papers. Because I've already done most of the papers in my my online AdMaths class, so it makes sense doing the same questions again, right? All right, so that's part D. So that takes care of question 1 here, guys, right? Moving on to question 2 on this paper. So every single year, CXC tends to give us a question on completing the square, right? So they can give us a complete square for a curve that has a maximum or a curve that has a minimum, right? So in this case here, we have a curve given by 3 minus 4x minus 2x squared. 3 minus 4x, right, minus 2x squared. Right, now I know that some students, right, lots of students have their own method of completing the square. Whatever method you are comfortable with, that is the method that you're going to go with, right? Don't try to learn something new right now, right? If you already know how to complete the square, you go ahead and do that, right? Go ahead and do that. Let's see. So this is the method that I normally teach my class, right? So minus 2x squared, I'm just writing it in a squared format first. 2x squared minus 4x plus 3. Right? So what I normally do, I will factor out the minus 2. So if you factor out minus 2, right? Now you all could try your method if you want and see if you get the same answer, right? So if I factor out minus 2, this is going to be x squared, right? Now what goes in the bracket here, and I normally have to show students this because they don't realize what I'm actually doing here. So minus 4x plus 3, right? What you're really doing here is dividing everything by minus 2. Divide this by minus 2, divide this by minus 2, right? So when I divide this here, I'm going to get x squared, right? Minus 4x divided by minus 2 is going to give me plus 4x, right? And this here is going to be minus 3 over 2. So this is what is going to be inside the bracket. So this is going to be x squared plus 4x, right? Minus 3 over 2, right? So if I were you, if I factor that out there, I'll just kind of do a quick multiplication in my head to make sure it's correct. So minus 2 by x squared, I'll get minus 2x squared. Minus 2 by 4x, you get minus 4x. And minus 2 multiplied by minus 3 over 2, you're going to get plus 3. So we're good to go there, right? So now, leave the minus 2 on the outside here. We vex with him, leave him right there. Next thing we're going to do, we're going to try to complete the square. When you complete the square, you're always going to have a bracket squared, and it's always going to start off with an x here. What comes next in the bracket is half of this value here. So this is going to be plus 2, right? What comes next, you're going to just write back whatever this term is here. So this is minus 3 over 2. What comes next is always going to be a minus sign, and you're going to square this 2 here. So that's going to be 4, right? But like I said, whatever method you are custom using, you go ahead and use that, right? CXC is not forcing us to use any particular method. I know some students learn off a formula. That's fine, right? So this is going to be minus 2, open brackets. We need to clean up inside it. So this is x plus 2 squared, right? Now, minus 3 over 2, right? Minus 4, right, is going to give me minus 11 over 2. Right? And this here is going to give me, make sure that 11 sounding correct. Hold on, find a number looking a little off. Yes, no. X plus 2 minus 3 over 2 minus, seems okay. So then I need to remove the big brackets. So this is going to be x plus 2 squared, right? Minus 2 by minus 11 over 2 is going to give me plus 11, right? So this is going to be 11 minus 2 by x plus 2 squared, right? Now for me, I kind of paranoid. I like to double check my answers sometimes, right? So I'm just going to expand this here and make sure we get the same thing, right? So this is 11 minus 2 by x squared plus 4x. Right? So I'm just trying to double check my answer first before I move on. Right? 11 minus 2x squared minus 8x minus 8. Something looking a little off here. Alright, hold on a sec. Oh. I don't see any problem, right? I have an error here. Right at the start, right? This here should have been 2, right? So hold on, let me fix that. Right, minus 4x yeah, this should have been minus 4. This should have been a 2 here, right? That should have been a 2. I really find the number looking a little off here. Right, so this should have been a 2x here, right? I'm sure somebody probably said that in the chat here, but so many things coming in at the same time. Yeah. Right, so I'm now checking the chat here. Yep, right. Okay, so this should have been a 1 here, right? Half of the 2, 1, right? You have to write back the 3 over 2, and then this is going to be minus 1, right? So this is going to be minus 2 by x plus 1 squared, right? And this is going to be minus 5 over 2. Right, so this is going to be minus 2 by x plus 1 squared plus 5. Right, so just let me know if this looking correct here, guys. Right, 5 minus 2. Right, let me know if that's correct. Yeah, sometimes we make mistakes, guys, right? It happens, right? It happens. You have lights in front of you, you're trying to switch between screens here, right? So yes, you do make mistakes sometimes, right? That's okay. If you all like the formula method, that's fine. Eh? Whatever method you are comfortable with, stick to that, right? Right. So people say they have that, great, right? So that is completed square. Now, sometimes some students, when they see, so that's this, right? So we did that here. State the coordinates of the maximum point. Could you all write down in the chat here for me, what are the coordinates of the maximum point? Because even though that seems simple, some students get it wrong. What are the coordinates of the maximum point? I've seen plenty correct answers here. Some people, not everybody has the correct answer, right? So if you want to work out the coordinates of the maximum point, sorry. So when you complete the square, there's a lot of information that we could get. So if you put x plus 1, all right, if you put x plus 1 equal to 0, therefore x is equal to -1, I want you all to know that this here is actually your equation for your axis of symmetry. So they could ask you that, right? So this is your axis of symmetry, right? That's your axis of symmetry, right? And this value here, this 5 here, sometimes they might ask you what is the maximum value or the minimum value of the function. It is always going to be the constant that you have here in the completed square. So the max point, right? The max point is simply going to be, right, -1, and it's going to be 5, right? Those are the coordinates of the maximum point, right? What CSEC also does, guys, is that they may ask us, and that's something they like to ask. They like to ask us to sketch this curve, right? They like to ask us to sketch this curve. So let me show you how you sketch this curve. I know in the maths exam, there was a question where they had to sketch a curve, and some students didn't know what to do, right? So let's see how we're going to sketch this curve here. Now you already know the coordinates of the maximum point. It is -1, 5, right? So here's what you know. You know the max point is -1, 5, right? That's what you know. The actual equation is 3 minus 4x minus 2x squared. 3 minus 4x minus 2x squared. Right? Now, if you want to sketch this curve here, you know it has a maximum point, so you know the graph is going to look like this. Right? This is how the graph is going to look. Right? And you know that this point here, the coordinates of that point here is actually -1, 5. Those are the coordinates of that point. We also know that this line here, this dashed line, is the axis of symmetry. So look at that. We know how the curve is supposed to look, and we know what the maximum point is. Now, you see this constant here, this number here, that's 3. That tells me that the y-intercept, right, the y-intercept is actually 0, 3, right? I don't know if you all realize that, but the constant in your quadratic gives you the y-intercept, right? So now, I need to put in my x-axis and my y-axis on this diagram here. So we had -1, right? So if I had to draw this, the axes here, I'll probably draw it like this. So this 5. So maybe, right, the x-axis is here, and the y-intercept is supposed to be 0, 3. So if this is 5 here, right, if this is 1, 5, 0, 3 might be somewhere here. So the y-axis might look like this, right? The y-axis might be here, and this point here is going to be 0, 3, right? So they like to bring questions where they will ask us to sketch a curve, right? Right? So whatever method you are comfortable with, right? I'm not forcing you to use any particular method, right? Whatever you're comfortable with, you go ahead with that, right? Let's see what the next question is here, right? So we had to, I just showing you how to sketch a curve. The next one here, we have a sum of $6,000. It's placed in a fund, right? So we know that arithmetic and geometric progressions can come in the exam. Let's take a copy of this here. All right, so we have some money, right? $6,000. It's placed in an investment fund, right, on January 1st, 2024. The fund earns an interest of 6% per annum, right? 6% per annum, right? So basically, this is compound interest we're talking about here, right? Now, January 1st, right? So that's at the beginning of the year. So Jan 1st, right? 2024. Right? The amount of money that we put into this thing here is $6,000. Right? That's the amount of money we put in the fund here. So what's going to happen is that throughout the year, it's going to get interest, right? And at the end of the year, or December 31st, you're going to have a certain amount of money. which will include the interest, right? So therefore, on January 1st, right, 2025, right, the amount of money that is going to be in the fund, right, what you would have to do is to take 6% of that 6,000 and add it to 6,000. So those of you not sure what we do here, what we're going to do here is actually multiply, right, by 1.06, right, multiplied by $6,000. That's what you're doing here, right? So if you're all wondering where the 0.06 come from, that's the 6% here, right? And the maths exam had something like this, and I worked it in a similar way, right? So what's happening here is that in the next year, you're going to multiply by 1.06. That's what you're doing, right? Then on January the 1st, 2026, right? What's going to happen here is that the amount of money in the fund is going to be 1.06 multiplied by all of this again. So therefore, this is going to be 1.06 squared multiplied by 6,000, right? Now, these investment questions, you have to be careful with them, right? So could anybody tell me what kind of pattern here, what kind of progression is this? Is this geometric or is it an arithmetic? What kind of progression is this we're looking at here? Right, I've seen everybody saying GP. Yeah, it is a GP, right? It is a geometric progression, right? So with this geometric progression, the first term is 6,000. That's A, right? Our R in this case here, right? Some people assume that the R is 0.06, but the R in this case is actually 1.06, right? So could you all work this out for me? Let me see if you all get this answer. I want to know the money, the amount of money in the fund on January 1st, 2028. How much money do we have in the fund on January 1st, 2028? Let me see if anybody can get this correct. Right? You see that same thing I'm talking about here, right? A lot of people not sure why is it 1.06. Now, if you want to work out the amount of money in the fund after 1 year, you have to take 6%, right, and multiply it by the 6,000, and then that value, you're going to add that to the 6,000. In effect, what you're really doing there is multiplying by 1.06. So if you all actually work out the total money by taking 6,000 and add it to 6% of 6,000, right, you'll get an answer. If you take 1.06 and you multiply by 6,000, you'll get the same answer, right? Yeah, so some of you are saying it in the chat. It's 100% plus the 6%, which is 1.06, right? Right, so be careful with those investment questions, right? You have to be careful with what we're using as R, right? Now, I'm seeing some people work it out already. A lot of people have the same answer, right? When it comes to questions like these, you have to be careful with the dates, right? You have to be careful with the dates. So this was your first term, right? This is T1. That's your first term, or that's A. This is your second term, right? This is your third term, right? So we want to get till 2028. So this is 2027. This is 2028, right? So therefore, this is T4, right? And this one here is going to be T5, right? So that's now 1,6,000. Right? So let's see. What some students tend to get confused with, they're not sure which formula they're using here. Some people use the sum formula, right? So there are two formulas when it comes to a GP. So to find any term, it's AR to the n minus 1, right? To find the sum of the first n terms of a GP, it's A by 1 minus R to the n all over 1 minus R. I think this formula is given to you in the exam, so it should be okay. So what I'm interested in is finding out what T5 is, right? So T n is given by AR to the n minus 1. So if you want to get the fifth term, right, it's simply going to be 6,000, right, multiplied by R, which in this case is 1.06, and it's going to be n minus 1, so that's 5 minus 1, and when you use your calculator, you're going to get a total of 7,574.86, right? Just remember, when you're working out money, right, money we normally round it off to 2 decimal places, right? A question like this might be worth about 5 marks, honestly, yeah? Right? Yep, somebody's asking about the formulas. Not all the formulas in the formula sheet at all. There are some formulas we have to learn off. Yeah, Darius. Right, some people asking how I get 5. That's what I said. Sometimes you may have to write it out, right? So you want to get on January 1st, 2028. Now you're starting this fund on January 1st, 2024. So start checking. 24, 25, 26, 27, 28, right? So therefore, I want to work out the fifth term. That's where the 5 came from. Yes, Darius. Yeah, that's true, right? That's true, right? But any one of the formulas, Darius, it'll work, eh? Any one of the formulas, right? Right, so that's the sum, right? That's the sum of the money in the fund. So be careful, eh? Some students, when they read this here, they think they're going to use this formula here, right? So you have to read the question and try to interpret what's happening here, right? So that is part, right? That's part B. Part C now here, right? Let's get out on a clean page as well. Hold on. Right? I know some of you all asking what paper is this. This is my sample paper, right? This is my sample paper. I don't know if you all realize this. There isn't sufficient AdMaths papers to practice anything, right? So Joshua is reading a suspense novel, right? On the first day, he reads 20 pages. Each day, he reads 4 more pages than the previous day, right? Determine the number of pages read on the 6th day, right? So first things first. What kind of progression is this? What kind of progression is this? All right, so people saying arithmetic progression, I agree, because you are increasing the number of pages read, right, by how much? By 4. You keep reading 4 more pages, right? Now here's what I want you to work out here for me if you can. I'm asking for the number of pages read on the 6th day. Could you all try to get an answer for me? How many pages did Joshua read on the 6th day? So CXE likes to give questions where it's a real life scenario, right? Not just a simple calculation with APGP. They tend to give us calculations involving real life scenarios, right? Right, I've seen a lot of people getting 40 as the answer. Let me see if that's correct, right? So, when it comes to an arithmetic progression, that's what we have here, right? So there's a formula for the nth term of an AP, and that is given by a plus n minus 1d, right? A plus n minus 1d, right? When it comes to the sum of the first n terms, you all need to know this formula as well. I think this is given in the exam, I'm not sure. This is 2a plus n minus 1d, right? So those are the 2 formulas for your arithmetic progression. Now in this case here, what's happening here is that on the first day he reads 20 pages. So that means a is 20. And if the number of pages read increases by 4, it means that the common difference is actually positive 4, right? And we want to work out how many pages he read on the 6th day. So therefore, you want to work out T6. So that is going to be A plus n minus 1D. So it's going to be 20 plus 6 minus 1, right, by 4, right? So that's going to be 6 minus 1 is 5. So this is going to be 20 plus 20. So therefore, he read 40 pages, right, on the 6th day. The next one here now, right, part 2, if he takes 15 days to read the entire book, how many pages did the book contain, right? So you're busy reading the suspense novel, find it going so good, right? How many pages does the book have? So this one here, we have some people getting catch with this one, right? Think about the scenario, you know, right? You're reading a book, right? And you read 20 pages on the first day. The second day you read 24. The next day you read 28, and so we keep going, right? He takes 15 days to read out his book, right? And what we want to do, we want to work out the total number of pages, right, in this book, right? So I see a lot of people getting 76, but I don't think that's the correct answer though, right? So what's happening here is this. When it comes to the pattern that we have here, you have 20, right? Then on the next day, you would have read 24. Next day, you read 28. And he kept doing this for 15 days. So therefore, what we're going to use this time here is your sum of the first n terms formula, right? N over 2 into 2a plus n minus 1d. Right? So you want to work out the sum of the first 15. Once I work this out here, this will tell me how many pages we have in the book. So this is going to be 15 over 2, right? 2a, so that's going to be 2 by 20, right? Plus 15 minus 1, right? By d, which is 4, right? So this is going to be 15 over 2, right? By 20 by 2 is 40, right? And this is going to be 14 by 4. And that's 56. So this plus 56. Right? So that's 96 multiplied by 15 over 2. And you're going to get 720. So the book actually has 720 pages. Right? So I saw one or two people had that as the answer. That's correct. All right. All right. Yes, Cohen. Good night. Good night. All right. All right. So this is part C, right? It's part C. Let's see what's happening here. All right. So that takes care of question 2, right? That takes care of question 2. Let's look at the third question. Now, in the third question in the exam, CSEC tried to cram a lot of things in this third question, right? In this third question, they try to cram a lot of stuff here. So one thing for sure, we will get a question on circles, right? We always get a question on circles every year. So this time here, right? I think I've killed the other type of question so many times in my class right now. I decided to put this one here. So we want to determine the equation of a circle with center O and radius 5, right? So this one here, we know the center of the circle and we know the radius, right? A lot of questions they bring sometimes, they give us the equation of the circle and we have to figure out what is the center and the radius. So I decided to put this one here instead, right? So we want to determine equation, right, of the circle, right? So what we're going to do, we're going to use the formula x minus f squared, right, plus y minus g squared, right, and that is equal to r squared, right? So the other form that CSEC can give us is x squared plus y squared, right, plus 2fx, right, plus 2gy, right, plus c is equal to 0. That's the other form. So we need to know both forms for the exam, right? Now what we're going to do, we're going to take the center. So in this case, it's going to be x minus 3 squared plus y minus 2 squared, right, is equal to 5 squared, right? Now what I normally do, I normally tell my class, here what? I want you all to learn of this expansion here, right? These expansions are very helpful. If I have to expand a plus b squared, that is actually a squared plus 2ab plus b squared, right? And if I have to expand a minus b squared, that's going to be a squared minus 2ab plus b squared, right? These are two very useful expansions when it comes to circles, right? So I normally tell my class, you need to know this, right? So this here is going to be x plus 3 squared plus y minus 2 squared is equal to 5 squared. So we're going to expand the first bracket. So this is going to be x squared plus 6x plus 9, right? And I'm just saying that because I know the expansion for this, right? Plus y squared, right, minus 4y plus 4 is equal to 25, right? So then you have to take your time now and try to carry everything on the left side. So this is going to be x squared plus y squared, right, plus 6x minus 4y plus 9 plus 4 minus 25 is equal to 0. So therefore the final answer is going to be x squared plus y squared minus 6x minus 4y, right? So this is going to be 9 plus 4 minus 25, and you're going to get minus 12 here, right? You all can just double check my answer if you need to, right? Right? I hope that makes sense, right? I hope that makes sense, right? Right, somebody's asking about the center minus f minus g, right? So remember, right, let me just show you something here quickly, right? Let me show you something here quickly. If I were to give you this here, I just want to double check my answer too, right? If I were to give you, so CSEC can give us a question like this. They can give us a circle like this, and then they can ask us what is the center and what is the radius, right? Now the general form for a circle is this: x squared plus y squared plus 2fx, right, plus 2gy, right, plus c is equal to 0, right? That's the general form. So if I wanted to work out the center, so I saw somebody put in the chat the center is minus f minus g. Yeah, that's true, right? So what we can say here is 2f is equal to minus 6. Therefore, f is equal to minus 6 over 2. So therefore, f is equal to minus 3, right? We can also say that 2g is equal to minus 4, and therefore g is equal to minus 4 all over 2. Let me just double check something here. Minus 3. That's something. Oh, this should have been a plus 6 here, right? This should have been a plus 6 here, right? So good thing I'm checking it over. So it should have been x squared plus y squared plus 6x, right? So let's put that here. This is plus 6x here. See how easy it is to make a little mistake in these exams, right? Right, so that's 3, and this g here is going to be minus 2, right? And the c here is going to be minus 12, right? Now, if the center is given by minus f minus g, it means that the center of the circle here is going to be minus 3 and 2, right? And if we go back here, you're going to realize, hey, that's what the center was, minus 3 and 2, right? Let's see if we get any 5 units now. So there's a formula to find the center, sorry, the length of the radius. So the radius is given by f squared plus g squared minus c, and you find the square root, right? So this is going to be, f in this case is 3, so this is 3 squared plus minus 2 squared, right? Minus 12, right? So that's going to be 9 plus 4 plus 12, right? So we get the same answer, right? We get the radius as being 5, so we're good, right? So therefore, I'm certain, right? I'm certain that this answer here, this here, is the correct equation for the circle, right? So you need to work both ways. You have to be able to find the equation of a circle if you know the center and you know the radius, or if they give us the equation of the circle, you have to be able to determine the center and the radius, right? Let's see what else we have here. So like I said, they love to bring circles, right? And normally when they give us a circle questions, they may ask us to find the equation of the tangent, or they may ask us to find the equation of a normal, right? So let's get a blank slide here. Now, when it comes to a circle, right, this is a circle here. Now, this is just for illustration purposes. It may not be accurate. So if this is O, right, and this is, let's say, P, right, that point P on the circle in my question here is 1, 5, right, and the center O, right, was minus 3, 2, right, that's the center O here. Now, if you join a line from the center to the point P, that's a radius, right? If I extend it further, that's what we call a normal. So this here is your tangent. So this is your tangent, and this here is my normal, right? Now again, I know some students who actually learn to formulas for this, and that's fine. If you can remember formulas, great. I just don't like to learn off plenty formulas, right? That's just my personal preference. So you want the equation of the tangent, right? You want the equation of the tangent. So you want this line here, right? So what I would do, I'd use a point O and P to find the gradient of the normal. So O is minus 3, 2, right? And P is 1, 5, right? So what I normally tell students to do, make sure and label. So call this X1, call this Y1, call this X2, call this Y2, right? So what I'm going to do, I'm going to work out the gradient of the normal. So this is the M for the normal, right? And that's given by Y2 minus Y1 all over X2 minus X1. So Y2 in this case is 5 minus 2 all over 1 minus minus 3. So therefore, this is going to be 3 over 1 plus 3 is 4. So it's 3/4. Right? Now, could you all put in the chat for me what's the gradient of the tangent? Could you all put for me what is the gradient of the tangent? Based on what I have here. Right, a lot of people saying negatively reciprocal, right? Yep, that's exactly what it is, right? So we just need to invert this number. So if you invert 3/4, you're going to get 4 over 3, right? And we need to put a minus sign in front of it. So that's the gradient of the tangent. Now, some students are able to work out the gradient of the tangent, but they end up using the wrong point in order to work out the equation. So here's the thing. some students end up use O instead of P. If you look at it carefully, the tangent only passes through the point P. So I must use the point P to work out the equation of the tangent, right? I can use O or P when I'm working out the equation of the normal, right? Because the normal actually passes through O and P. So in this case here, your equation of your tangent is going to be minus 4 over 3 x plus c, right? So the only thing we need to do now is to figure out what c is. So we'll use the point P. So P is 1, 5. So what that means is that x is 1 and y is 5, right? So therefore, what we're going to do, we're going to substitute this. So this is going to be 5 is equal to minus 4 over 3 multiplied by x, which is 1, plus c. So therefore, c is equal to 5 plus 4 over 3. So therefore, c is equal to, right? That's 19 over 3. Right? So therefore, the equation of the tangent is equal to minus 4 over 3x plus 19 over 3. Now, here's the thing, guys. Try not to work in decimals, right? Some students, they work their answers and they work in decimals. Don't do that, right? Don't work in decimals. Try your best to work in improper fractions. That's my suggestion to you, right? Yeah, so some people ask them what paper. Yeah, these are my sample papers, right? Somebody asks if you can use y minus y1 is equal to m into x minus x1. Sure, you can use that, right? So that's something that I used to use back in when I was in Form 4, Form 5, and Form 6 all the time, right? But when I started teaching maths, I realized some people get a little confused with that. So that's why I use the y equal mx plus c method to work out c, right? But yes, Muzamil, you can go ahead and do that. That's fine. The live is being recorded, so you can access it after. That's fine. Right, let's see what's happening here now. So, right, so that's part A, right? Circles. So we know circles coming for sure, right? Next part here now. We have two position vectors, right? Let me... Right? Now, obviously, I can't cover every single thing in the syllabus, right? My exam preparation usually lasts about 4 months, right? All right, so I have two vectors here, right? I have OA and I have OB. And we want to determine the unit vector in the direction AB, right? Now, what I normally advise students to do is to do a little sketch, right? And that sketch is basically for us to kind of visualize what's happening here. So OA is 2, 5, right? So 2, 5 could be somewhere here. This is O, right? And this is A here, right? So this vector here is OE, right? OB is minus 2, 3, right? So minus 2, 3 is going to be somewhere here, right? So this is the vector OB, right? Now the question says to find a unit vector in the direction AB. So first things first, we need to figure out what is the vector AB. Based on the diagram here, right? AB is actually equal to AO plus OB, right? So AO is in the reverse direction of OA, so that's going to be minus 2i minus 5j, right? And then we're going to add that to the vector OB, which is minus 2i plus 3j, right? So this is going to be minus 4i minus 5 plus 3 is going to give you minus 2, right? So this is the vector AB here, minus 4i minus 2j. Now, if you all see any errors, let me know. So people, this is not the 2024 paper, right? I don't know why people feel I would leak a paper, right? Right, the same thing happened for the maths. Everybody thought I was doing maths paper. Nope, nope, nope. I don't deal in those kinds of things, right? All right, so I have the vector AB here, right? I have the vector AB here, right? Now, if you check your formula sheet, you're going to see on the formula sheet, if you want to work out a unit vector, it is actually the vector divided by the magnitude of the vector. If you look at the formula sheet, you'll see that. So what I need to do, I need to figure out what is the magnitude of the vector AB, right? To do that, all I'm going to do, I'm going to say minus 4 squared plus minus 2 squared, right? And we're going to find the square root, right? So in this case here, that's 4 4s are 16 plus 4, that's 20. So that's going to be root 20. Now you can leave your answer in root format if you want, right? So if you want to get a unit vector in the direction of AB, it is going to be the vector AB, which is minus 4i minus 2j, right? And you're dividing that by root 20, right? You can leave your answer like that, or some people write it like this, 1 over root 20 by minus 4i minus 2j, right? Right, so that's part 1. Part 2, they tend to bring this very often to work out the angle between two vectors, right? So this here is the angle that we're looking for here. Let's call it theta, right? And we can work out the angle theta by simply doing what we call a dot product, right? So let's see. You want to work out the angle theta here. So we need to work out. So we need to know what is OE dot OB. Right, that's something we need to work out. That's a dot product, right? So OA was 2i plus 5j, right? And you're going to dot this, right, with minus 2i plus 3j, right? Now, when it comes to vectors, right, right, we have scalar product. When it comes to vectors, we have something called a dot product, right? And the first time I heard about a cross product is when I was doing engineering maths in UE, right? So there's something called a cross product as well, right? To work out the dot product here, it's going to be 2 multiplied by minus 2 plus 5 by 3, right? That's how we work out a dot product here. So that's going to be minus 4 plus 15, right? So that's going to give us what, 11, right? So that's our dot product. Next thing we need to work out, what is the magnitude of OA. So the magnitude of OA, right, is given by 2 squared plus 5 squared. And we find the square root, right? So that's 2 2s are 4, 5 5s are 25. So that's root 29, right? You don't need to work out the decimal here yet. We need to work out the magnitude of OB, which in this case is going to be minus 2 squared plus 3 squared, right? So that's 3 3s are 9 and 4 is 13, right? So that's my dot product and that's my magnitude. So if you want to work out your angle, right? And I think in the formula sheet, I'm not sure how it's written, but A dot B is equal to magnitude of A, magnitude of B cosine theta, right? This is the formula that we need to know. So if you want to work out cosine theta, so cosine the angle that we want to find is simply the dot product, right? So in this case, it's going to be OA dot OB, right? All over the magnitude of OA multiplied by the magnitude of OB, right? So therefore, cosine theta is equal to the dot product here. In this case, is going to be 11 all over root 29 by root 13. So therefore cosine theta, so you're going to get a decimal here now, right? I'm getting 0.56, sorry, 0.567. So therefore theta is equal to arc cos 0.567. Right? So therefore theta is equal to 55.5 degrees. Right? So that's my angle there. So be prepared to work out a dot product, right? Be prepared to work out a dot product. They tend to bring that a lot in the exam, right? Yeah, you all could go ahead and use the one in the formula sheet. The formula sheet, I think, gives you, I think on the formula sheet it's written like this, right? I think on the formula sheet it is cos theta is A dot B, right? All over mod A mod B, right? So it's in the formula sheet, this particular formula. So don't stress, it's in the formula sheet, right? Right, so that takes care of part B. Part C now. Now, they did not bring a question on sectors in the 2023 paper, right? They brought one in 2022, but none in 2023, right? So let's have a look at what I have here. All right, so this is my question here, right? All right, so we have a diagram here, right? We have OAB is a sector of a circle with center O and radius 4.5 cm. AX and BX are tangents to the circle at a point A and B respectively, right? So once you see the word tangents, right? Remember this here is a radius and it's 4.5, right? So if they tell us that AX is a tangent, it means that this angle here is 90 degrees, and it also means that this angle here is 90 degrees. Pay attention to things like this when it comes to a sector, right? If you have a tangent to a circle or a sector, it is going to meet your radius at 90 degrees, right? And we know the angle here. The angle here is given by 1/3 pi, right? So if the angle is 1/3 pi, it means that the angle here has to be in radians. Now here's what the question is asking, right? In the first part, they want to work out the perimeter of the shaded region, right? So if you want to work out the perimeter of the shaded region, we must first figure out what is this curved piece here. You need to know that arc. You need to know this length here, and you need to know this length here, right? So we're going to have to use some trigonometry in order to work out AX and XB, right? So the first thing I'm going to do, I'm going to work out the length of the arc AB. So AB, right, is given by R multiplied by theta, right? That's the formula to find the length of arc. So R in this case is 4.5, right? And you're multiplying that by 1/3 pi or pi over 3, right? So again, calculator for this. So 4.5 multiplied by pi over 3, and you're going to get about 4.71, right? So that's that length of the arc here, 4.71 cm. Next thing we need to do, we need to figure out what is AX. Now the thing is, AX, this length here and this length here, they are going to be the same, right? Based on the geometry of the figure, right? Those are two tangents, so AX must be equal to BX. So what I'm going to do here, I'm going to draw a dashed line to separate this thing here, right? I'm going straight up to X. So therefore, what I have now, I have two right angle triangles, right? So what that is going to do, that is going to allow me to figure out what is AX. Now, if you draw that dashed line there, what you're doing is dividing the angle into two equal parts, right? So pi over 3, if you divide it by 2, this angle here is now pi on 6, right? And this angle here is also pi on 6. So you're dividing that angle into two equal parts. So what I'm going to do now, I'm going to use trigonometry in order to work out AX. Just out of curiosity, could you guys work out AX for me? I want to see what you all get for AX. Try to work out the length AX for me. Let me see what you all get. I see some people saying add maths unnecessary. It depends. It depends on what you're gonna do later on in life, right? If you plan on doing engineering, right, you're gonna need to know some add maths, a lot of add maths, right? So as you all know, I'm an electrical and computer engineer. So you live and breathe that kind of maths, right? You live and breathe that kind of maths when it comes to engineering, right? Even I also have a management degree as well, and if you do things like economics and there are certain courses where you have an advanced there has to be an advanced understanding of maths to be able to do some of these things, right? Right, so I've seen some people work it out, right? Some people asking why is pi on 6? You're dividing pi on 3 by 2, right? Because of the symmetry of the figure, you're dividing that angle there by 2, right? So remember the angle AOB was pi over 3. So therefore, I'm dividing that by 2, you get pi on 6. Okay, so let me just do something quickly here. So you have a right angle triangle. Right, we have a right angle triangle here. Right, this is pi on 6, right? This here is A, this is X, and this is O, and we know this length here is 4.5 cm. So therefore, you need to label your triangle. So this is going to be opposite, right? And this here is your hypotenuse. So therefore, this here, the 4.5 is your adjacent. So therefore, we have opposite over adjacent. So therefore, we're going to use tan in order to figure this thing out. So it's going to be tan theta, right, is opposite over adjacent, right? That's what I'm going to be using. So therefore, tan. Now, this is where things get a little tricky here, guys, because you have to pay attention to your calculator here now. So you need to convert your calculator to radians in order to work this question. So the opposite side is AX, we don't know what that is, and you're dividing that by your adjacent, which is 4.5. So what we're going to do, we're going to cross multiply. So therefore AX is simply going to be 4.5 multiplied by tan pi on 6. Right? I know I've seen some answers in the chat here. Let's see if that answer correct. So my calculator, I'm putting it to radians first of all, right? Radians, and 4.5 multiplied by tan pi on 6, close brackets, right? And I am getting 2.60. I don't know if anybody got this one here. I am getting 2.60. Right, so some people got 2.6, great, right? So so just remember, right? Just remember, you have to switch your calculator to radians when you work this out, right? Right, so the question asks for the perimeter. So the perimeter of the shaded region is simply going to be the length of the arc, which is 4.71, right? Plus AX, which is 2.60, right? Plus BX, which is also 2.60, right? So this here is going to be 4.71 plus 2.6 plus 2.6. And you're going to get 9.91, right? 9.91 cm, right? Right, I see some people asking about converting to radians. So you have an option. You can leave your calculator in degrees and convert the pi on 6 into degrees. Pi on 6 is actually 30 degrees, right? So some people said they did that. Right, so trying to give a comprehensive question here, really, yeah? So the next part, part 2, we want to work out the area of the shaded region, right? We want the area of the shaded region. So let me just copy this to a slide here. Hold on. right? So we already worked out part 1, right? And we want to work out the area of the shaded region. Now, just look at the logic of this here, right? So what we could do to find the area of the shaded region, right? We can find the area of the whole shape and subtract the area of the sector, right? Now the area of the sector here, that white piece, is given by this formula. Area is a half r squared theta. So you all need to learn this formula, please, right? So in this case, it's going to be a half multiplied by r. R is 4.5, right? And you're multiplying by theta. There's no sine, there's no tan, there's nothing involved here, right? So this here is pi over 3 in radians. So this area is going to be 0.5 multiplied by 4.5 squared multiplied by pi over 3, right? And I'm getting 10.6, right? So that's the area of the white piece that I just worked out here, right? What I need to do, I need to work out the area of the whole thing, the whole shape, right? Now, if you think about it, we just divided this up here into 2 right angle triangles, right? We just divided this up into 2 right angle triangles, right? And we worked out the length bx. Make sure I'm saying this correct. Yeah, we worked out the length bx, right? How much we got? We worked out ax and bx. We got 2.6, right? So this length here is 2.60 cm, right? And this here is also 2.60, right? So what you could do, you can find the area of one right angle triangle and multiply by 2. So the area of the whole shape, right? So the area of the entire shape here is going to be, so the area of one triangle is going to be a half multiplied by the base. Well, doesn't matter which one you take it as, but 4.5 multiplied by 2.60, right? So that's the area of one triangle, but you have 2 of them. So you're going to multiply this by 2. So that is simply going to be 4.5 multiplied by 2.6, and you're going to get 11.7, right? So 11.7 cm squared is the area of the whole shape. So the shaded region, right, is simply going to be the whole shape, which is 11.7, minus the white part or the sector, that's 10.6, right? And you're going to get what? 1.1. Right? So that's 1.1 cm squared, right? So make sure you know your formulas for length of arc and right? So the last part of the question. So the third question, like I said, CSEC tends to squeeze a lot of things in that third question there, right? You have vectors, you have sectors, you have circles, and you also have trigonometry, which is something that generally students don't like at all, right? Let's see this one here, right? Have a look at this question here. So given that sine A is 3/5, right, and cosine B is 15/7, where A is obtuse and B is acute, determine cosine A plus B, right? Cosine into A plus B. So this is a compound angle formula, but this question here could be worth plenty marks in the exam, right? So let's first start off. We want to work out what is cosine A plus B, right? Now, by the way, these compound angle formulas are given to you in the exam, right? So if I expand this, this is going to be cosine A, cosine B, right, minus sine A, sine B, right? So this expansion here could be found in your formula sheet, right? Now, if I want to work out this here, I need to know what is cosine B, I need to know what is cosine A, I need to know what is sine A and sine B. But this question is a bit tricky because they said sine A is 3/5 and angle A is obtuse. Now this is where things become a little tricky here. You all need to understand your quadrants in order to be able to answer this question. So ASTC, or what I tell my class, all school teachers costs, right? So if angle A is obtuse, you need to be able to figure out which quadrant angle A belongs to. So if it's an obtuse angle, it means that angle A is actually in this quadrant here. This is where angle A is, right? Now, sine A is 3/5. Now, since sine is positive in the first and second quadrant, right? What I can do, so you already know what sine A is, right? I need to figure out what is cosine A. So I'm going to create a right angle triangle here, right? Now let's call this angle alpha, right? This is a right angle triangle here, right? Now sine A is 3/5. So sine of any angle is going to be opposite over hypotenuse. So this is going to be 3 here, and this here is going to be 5, right? So what I can do, I can work out this length. I need to figure out this length here. To figure out that length, we're going to use Pythagoras' theorem. So therefore, that length is simply going to be 5 squared, right, minus 3 squared, right, and you find the square root. I'm using Pythagoras' theorem here. So this is 25 minus 9 square root. So this is going to be square root 16. So this is going to be 4, right? So therefore, this length here is 4. So what that tells me is that I can figure out what is cosine or sine of alpha, or theta in this case here. So let's see. For cosine E, right, cosine is adjacent over hypotenuse. So therefore, cosine A is going to be 4 over 5, right? So therefore, I know what cosine A is. I don't know what cosine B is as yet, right? For sine of A, well, I know what that is. That was 3/5, right? And I still need to figure out cosine B, and I need to figure out sine B. So let's see what's happening with B now. So angle B is acute. So if angle B is acute, it means that angle B is found in the first quadrant, right? Now in the first quadrant, all angles are positive, so we should be okay. So the angle in this case here is 15 over 17. So this is angle B here. Now, if it's cosine, cosine is adjacent over hypotenuse, right? So that means that here is going to be 15 and here is going to be 17. So we need to figure out this length here, right? So to do that, we're going to just say 17 squared minus 15 squared, square root. So that's going to be right, that's going to be the square root of 64. So this is going to be 8, right? So this length here is going to be 8 here. So that means, so let's start with cosine B now. So cosine B is adjacent over hypotenuse, which is 15 over 17, right? And sine B is opposite of hypotenuse, which is 8 over 17, right? So this question, do it probably carry a lot of marks, right? Yeah, all the compound angle formulas are there, guys. All the compound angle formulas are there, right? Yeah, I know they gave cosine B, but we still have to work out sine B though, right? So to work this out here, this is going to be 4 over 5 multiplied by 15 over 17, right? So this is 12 over 17 here, right? Minus, right? And this is going to be 3/5 multiplied by 8 over 17. Right, it's 24 over 85. Right, and the final answer is simply going to be 36 over 85. Right? Now, there are other kinds of questions that can come on trigonometry, right? But like I said, I can't cover all of them, right? In my online classes, I would have covered most of what they should know, right? Right, so that takes care of the third question on the paper, right? Moving on. Question 4, right? For me, this is usually the nicest question on the paper. I like differentiation, right? I like differentiation. Right, that's all. Some people are saying cosine A, will it be negative? Let's back up a sec here. Let me see. Double check. Maybe I have an error. Let's see. Right, so we have a query here. Let me double check this. Let's erase this, right? Because I feel that query is incorrect. Right? Let's see. You said cosine. Let's see what you all say in the chat. Right, some people are saying cosine A should be negative, right? Let's double check that. All right, so A, sine A is 3/5, right? That was fine, right? Cosine A, yeah, you all are correct, right? You all are correct actually. So angle A, right, is in your second quadrant, right? Angle A is in the second quadrant here. But when we're working out cosine is going to be negative in the second quadrant, right? So good spot there, guys, right? It should be negative. You're sure, right? All right. So this is going to be, so this should have been negative 12 over 17. Right, on 3 over 5. Right, so just double check my answer here. I'm getting minus 12 over 17 minus 20. Right, I'm getting minus 84 over 85. Right, so those of you who spotted that, right, excellent job, guys, right? Right, so make sure when you're solving any kind of trigonometric equation, just remember all angles are positive in the first quadrant, right? Only sine is positive in the second, only tan is positive in the third, and only cosine is positive in the fourth quadrant, right? So because angle A was an obtuse angle, it's in the second quadrant. So therefore, sine of angle A is going to be positive. But if I try to work out cosine of angle A, it's going to be negative, right? So this here should have been a negative, right? All right, so I'm moving on to the differentiation question, right? So, like I said, differentiation, love differentiation, right? So we have two things to differentiate here in part 1. On some more pages. Right, so the first one is 3x squared sine 7x. Right, so we want to differentiate this here. So in terms of how you do this or how you write this in the exam, right, what you can do, you can put d over dx, right, and put all of this in brackets here, right? Or some students say let y equal to that and they work out dy dx. You can do that as well, right? So you have options. So what I'm going to do here to work this out here, that is clearly, right, the product of two functions, right? Now, if you're going to use your product rule, you have to be able to identify two products. So this is a function of x here, and this is also another function of x, right? So we're going to use the product formula in order to differentiate this, right? Now, I normally like to tell my students the process, right? I don't like them to just learn off the formula. So it's going to be the first term, which is 3x squared, and you're going to multiply that by the differential of the second term. So you're differentiating sine 7x. When you differentiate sine, you're going to get cosine. But when you differentiate sine 7x, you're going to get 7 cosine 7x, right? Plus, because it's the product rule we're using, it's going to be the second term, which is sine 7x, right? Multiplied by the differential of the first term, which is going to be 6x, right? So all I'm doing here is applying my product rule. So we need to clean this up a little bit. You don't want this 7 here to be in the middle. So you're going to write this as 21x squared cos 7x, right? Plus, that's 6x. You're going to bring it to the front. It's going to be 6x sine 7x. Right? Right? Let me know if you all have any questions about that answer though, eh? Right? Just in case, right? It's very easy to make a mistake sometimes here. So that's the answer for part 1, right? That's product rule. For the second one, right? The second one here, so that takes care of this. We have 3x minus 1 over 2x plus 4. So 3x plus 1 all over 2x plus 4. Right? So again, if you want to write that in a way for CXC, you can write d on dx of all of this, right? So we differentiate in this. Again, I like to teach process, right? Not so much learning of the formula. So it's going to be the bottom, which is 2x plus 4, right? Multiplied by the differential of the top. When you differentiate the top there, you're going to just get 3 minus the top, which is 3x plus 1, multiplied by the differential of the bottom, which is going to be 2, right? All over the bottom squared. So this is going to be 2x plus 4 squared, right? So all I've done there, I'm applying what we call the quotient rule, right? You're applying the quotient rule because you have a function as your numerator, function of x, and you have a function of x as a denominator as well. So we're using the product rule. Now, let's simplify the top a little bit here. If we simplify the top, you're going to get 6x, right, plus 12, right, minus 6x minus 2 all over 2x plus 4 squared, right? Now we're not going to expand the bottom. You can leave the bottom like that. 6x minus 6x will cancel. 12 minus 2 is 10. So the answer is going to be this. Alright, let me see what happened here. 3x minus 1. What you all saying here? Oh, 3x minus 1. Alright, hold on. Yeah, that happens when you're switching between slides here, right? So you all saying is up. Let me change this here. Right? The problem is you don't have one big whiteboard here, so you're kind of switching between between slides, right? So this is minus 1, so this should have been a minus 1 here, right? How does that affect anything? The bottom by the differential of the top minus the top by the differential of the bottom. So when you multiply this out, you're going to still getting minus 6x, but you're going to get plus 2. That makes sense? Yeah, get plus 2. So therefore, you're going to get 14. Right? Let me know if that's correct there. Right? Thanks for the corrections, guys. Right? Yes, some of you are saying, so if you have to use sine of, let's say, 2x plus 1 in brackets, we're going to use the chain rule in order to do that, right? right? So expect something like this, right? Expect questions like this, right? Either they may not bring both of them in the exam, but they might bring one of them at least, product or quotient, right? Let's see what else I have here. All right, so they haven't brought a question like this in a little while as well. Rates of change, connected rate of change, right? So I believe I did one like this in my class on Saturday. Yeah, I think we did one like this. All right, so here's what we have to do in this question here, right? So the volume V of a sphere of radius r is given by 4/3 pi r cubed, right? The radius of the sphere is increasing at a rate of 0.01 centimeter per second. Find in terms of pi the rate of change of the volume of the sphere when r is 0.25. Now when you guys get a question like this, what you need to do, you need to kind of see what information is given here. So they said the radius is increasing at a rate of 0.01. So that means that dr dt, so you have to extract the information from the question. This is actually 0.01 cm s to the minus 1, right? So that's dr dt. The next thing now, we want to work out what is the rate of change of volume. So therefore the question that they are asking us here, right, or what they want is dv dt. That's what the question wants, you know. What is dv dt, right? So here's what we're going to do. We're going to start off with the formula for the volume, which is 4/3 pi r cubed, right? And the first thing I'm going to do, I'm going to work out what is dv dr, right? From this, I can get a differential of the volume. So if I differentiate this, I'm going to get 4 pi r squared, right? So that's the formula, or that's what I get when I find dv dr. Next thing I'm going to do, I'm going to plug r is equal to 0.25 into this here. So we're going to say when r is equal to 0.25, right, dv dr is equal to 4 pi multiplied by 0.25 squared, right? Now the question wants the answer in terms of pi, so don't touch the pi at all. So 0.25 squared multiplied by 4, and you're going to get 0.25. So this here is 0.25, right, pi, right? So that's dv dr. Now the question wants me to work out dv dt. So we need to write a connected rate of change formula here. So dv dt is equal to dv dr multiplied by dr dt, right? So dv dr is 0.25 pi. We just worked that out. And then multiplying that by dr dt, which is 0.01, right? So all we need to do is to work out 0.25 multiplied by 0.01, and you're going to get 0.0025, right, pi, and this is dv dt, so it's going to be cm cube s to the minus 1, right? Now they haven't brought one like this in a little while, that's why I have it here. Right, this is connected rates of change, right? This is connected rate of change. Right, as far as I know, this is not off the syllabus though. Yeah, we have a probability question here. Question 6 will have a probability inside here, right? Yeah, they can ask this. This is connected rate of change, right? This is not off the syllabus as far as I know. Right, so that's part B. Part C definitely can come in your exam, right? They love to bring this particular question here, right? Part C. So let's have a look at part C here. right? Finding the coordinates of stationary points on a curve, that is something that they like to bring, right? All right, so we have a curve given by this formula here. And the first thing we want the coordinates of the stationary points on the curve. Very common exam question. So y is equal to x cubed right, plus 3x squared minus 8, right? So if you want to find the coordinates of stationary points on a curve, the first thing we need to do is to find dy dx, right? So dy dx is equal to, this is going to be 3x squared plus 6x, right? That's dy dx. Now, at a stationary point, dy dx equal to 0. So you're going to say at a stationary point, is equal to 0, right? So if dy dx is equal to 0, all we're going to do, we're going to say, all right, well, 3x squared plus 6x is equal to 0, right? Now, this is a quadratic, right? And what you could do, you can say, all right, 3x, open brackets, x plus 2 is equal to 0, right? 3x by x is 3x squared, yeah. So that's how you factorize something like this, right? And we're going to find the two x values. So we can either say 3x is equal to 0, and therefore x is equal to 0. So that's one x value that we have. Also, we can say that x plus 2 is equal to 0, and therefore x is minus 2. So these are the x values here of the stationary points. What we're going to do, we need to figure out what y is. And to get y, you need to plug that into your original equation, right? So y is going to be equal to 0 cubed plus 3 by 0 squared, right, minus 8, right? So therefore, this is going to give us minus 8, right? So therefore, one stationary point is going to be 0 minus 8, right? That's one stationary point. The next stationary point now, we're going to substitute minus 2 into that same equation there. So that's minus 2 cubed plus 3 by minus 2 squared minus 8. And this is going to work out to minus 2 cubed is minus 8 plus 12 minus 8. And you're going to get minus 4. Right? So that my next stationary point here is going to be minus 2 minus 4. Let me know that making sense, huh? Thanks for the correction. My name is not Terrence, right? I don't know where people get that from. Right? You just let me know if I've seen some people saying 0 minus 8 minus 2, 4, right? So, right, so these are my stationary points here, right? So that usually they give us a good bit of marks just to work that out. The next thing we need to do, we need to figure out what is the nature of the stationary points. When it comes to the nature of stationary points, what we need to do, we need to find our second derivative, right? So you already have dy dx, you're going to make use of that. So 3x squared plus 6x. So dy dx, right, is 3x squared plus 6x, right? So we're going to find our second derivative, and this is how you write it, right? d2y dx squared, that's how we write this, right? So when you differentiate 3x squared, you're going to get 6x, right, plus 6. Now the two stationary points that we have are 0 minus 8. So 0 minus 8. And the second one was minus 2 minus 4. So what we need to do, we need to plug those values into the second derivative. So when x equals 0, your second derivative is going to be 6 by 0, right, plus 6. And you're going to get 6. Now, we don't really care about the value. What we care about is the sign. That's what we care about. So could you guys tell me 0 minus 8, is that going to be a max or a minimum point? I've got a positive value for your second derivative here. Is that going to be a max or is it going to be a min? Right, so a lot of people say minimum, right? Yes, it's going to be a minimum, right? So this here is a minimum point. So what I was telling my class on Saturday is that in my brain, when I see a positive number, I think it's going to be a maximum, right? But it's the reverse of what I think it's supposed to be. So when you get a positive value for your second derivative, it's a minimum point. Let's work this one out here now. So when x is equal to minus 2, your second derivative here is going to be 6 by minus 2 plus 6. So that's going to be minus 12 plus 6, and you're going to get minus 6. So obviously, if we get a negative sign here, right, this is going to be a max point, right? That's going to be a max point. Right? This is a typical examination question that you have to be able to answer, right? Right, so I see somebody say about the smiley face. I think some of my students told me the same thing, about some smiley face thing. Right, so moving on. Right, so we have that here, we have this. The third part was to find the equation of the tangent to the curve at that point. Right, find the equation of the tangent to the curve at that point. So the thing is, we already know what dy dx is here. We have that already. So what we can do, we can work out the point is 1 minus 4. So p is 1 minus 4. Right, dy dx is remember dy dx is also called our gradient function, right? 3x squared plus 6x. So all we're going to do, we're going to say when x is equal to 1, dy over dx is going to be 3 by 1 squared plus 6 by 1. Right, so this is going to be 9. So therefore 9, so the gradient of the tangent right is equal to 9. Right, so therefore the equation of the tangent is y is equal to 9x plus c. Right, and to figure out c, I'm going to use the point p in order to do that. So therefore x is 1, y is equal to minus 4, right? And in this case here, we're going to substitute. So you're going to get minus 4 is equal to 9 by 1 plus c. So therefore c is equal to minus 4 minus 9, right? So therefore c is equal to minus 13. So therefore the equation of the tangent is y is equal to 9x minus 13. Right? I don't think you all should leave out any question in the exam though. All right, so that takes care of the differentiation question, right? So we just have integration and statistics, right? So this one here is our integration question, right? Now just remember, in question 4 and 5, you could also get kinematics in those questions, right? So the first one here, we have a simple integral in order to perform. So we want to integrate 1 minus 3x to the power 4. So integral of 1 minus 3x to the power 4 dx, right? Now, CXC tends to bring this sometimes in the exam, but the formula that some of you all may have learned is this: ax plus b to the power n. If you want to integrate this, right, what you'll get is ax plus b to the power n plus 1 all over a by n plus 1, right, plus c, right? That's the formula that you should have learned at some point. But if you look at this here, right, if you look at this here, it's written a little differently. So what I normally tell students to do is to write this as 3x plus 1, right, to the power 4. And now we can integrate using the formula here, right? So in which case, it'll be minus 3x plus 1 to the power 5. Because you're adding 1 to the index, right? And this is going to be a by n plus 1. So it's going to be minus 3 multiplied by 5. So this is minus 15 plus c, right? Always remember, when you integrate something, you must include your constant, right? Right, some people saying, yeah, pure maths, A-level maths. I don't teach A-level maths, right? Not too familiar with the current syllabus, right? I come from the Cambridge era, so when it comes to keep maths, no. Right, the second one here now, we have an integral that has trigonometry in it, right? Right, so this is what we want to integrate here, right? This is what we want to integrate. So for this one here, right, this 2 here is a constant in front of this, right? So you have to ask yourself, when you integrate sine, what do I get, right? When you integrate sine, you're going to get negative cosine. But we have to treat with this here, this 2 in front is here. So this is going to be 2, right, multiplied by, so the integral of sine is going to be negative cosine. So this is going to be negative a half, right, cosine 2x, right, minus, right, the 3's are constant, so that stays on the outside. Now if you integrate cosine, you're going to get sine, but because of this 4 here, we need to treat with that. So that's going to be a quarter sine 4x, right? So what I'm doing here, I'm applying my rules for integrating trigonometric functions. So this is going to be minus cosine 2x, right, minus 3/4 sine 4x. Right, so that's my second part there, right? The third part, this is also a very common question that comes in the exam. If they give us dy dx and they ask us to find the equation of a curve, right? So you could be given what your gradient function is, right? And then you could be asked to find the equation of the curve, right? So we have a curve here, and that curve is given by 6x plus 7. So dy over dx is equal to 6x plus 7. right? And you want to work out equation with curve. So if you want to get y, all we need to do, we need to integrate dy dx. So this is 6x plus 7, right? So when I integrate this here, if I integrate 6x, I'm going to get 6x squared over 2 plus 7x plus c. I can simplify this a little more. So this is actually y is equal to 3x squared plus 7x plus c, right? So the only thing missing now is to figure out what is this c here. So to figure out the c, we're going to use this point here. So this point, which is on the curve, your x value is 1 and your y value is going to be 8, right? So we're going to just substitute into that equation to figure out what c is. So therefore 8 is equal to 3x squared. So this is going to be 3 by 1 squared plus 7 by 1 plus c. So this is going to be 8 is equal to 3 plus 7 plus c. So therefore 8 is equal to 10 plus c. So therefore c is equal to 8 minus 10. So c is equal to minus 2, right? So the equation of the curve is actually y is equal to 3x squared plus 7x minus 2, right? So be prepared to find the equation of a curve if you are given dy dx. Right? That's usually a straightforward question if you know how to integrate, right? Part C now, I have, right, so I have a kinematics question here. Now there are two ways CSEC can bring a kinematics question. They can bring a question where we have constant acceleration, right? So you could be given something that has constant acceleration, right? Or we can have something that has variable or nonlinear acceleration, right? So this question here, right? A particle travels in a straight line so that t seconds after passing a fixed point O, the velocity is given by this formula here. So v is equal to minus t squared plus 5t minus 4. And they want us to work out the distance between the particle's two positions of instantaneous rest, right? Now we have a formula for velocity here, right? Now if you look at the formula, right? If I were to do a little sketch, right? And this is time, and this is v, right? Based on the formula, you know that this graph is going to have a maximum point, and it's a quadratic. So this graph actually looks like this, right? So your velocity graph looks like this, right? Now they said find the distance when the particles the distance between the particles' two positions of instantaneous rest. Now when they tell you instantaneous rest, they mean v is equal to 0. Anytime we see the word rest, we know that v is 0. So v is 0 here and here, right? So those are two times, and we don't know what those two times are. But we want to work out the distance between those two times. So therefore, this is a velocity time graph. So you want to work out this area here. That's what you want to work out. So before you can do anything, you need to figure out those times. So I'm going to put v equal to 0. So this is going to be minus t squared, all right, plus 5t minus 4 is equal to 0. So I don't like to work with a negative sign in front of t squared. So multiply everything by minus 1. So we get t squared minus 5t plus 4 is equal to 0. Will this work out? Hopefully. If I factorize this, alright, put a 1 here, put a 4 here, and put a minus and a minus. Yep. So therefore, t minus 1 is 0. So therefore, t is equal to 1. So therefore, this time here has to be 1. And then t minus 4 is equal to 0. So therefore, t is equal to 4. So therefore, this time here is 4. Right? So if I want to work out the distance between those two times, so the distance, let's call it s. When you integrate your velocity, you're going to get your displacement. So this is going to be 4. So you're integrating between the limits of 4 and 1. 4 minus t squared plus 5t minus 4 dt. So therefore, if I integrate this, I'm going to get minus t cubed all over 3 plus 5t squared over 2 minus 4t, and your limits will be 4 and 1, right? Could you all work that out for me? Work out that actual value for me. Right, I see people getting answers here. I didn't work it out yet, so let me see it. So 4 cubed. Right, that's not. Right, so these are the numbers I'm getting here. So I'm getting the same thing that some of you all are getting, 9 over 2 meters. Right, I'm getting the same thing as well. Right, I know some of you all probably use, those of you have the fancy calculator, right? So those of you have the Casio, right? You can use the Casio to work it out in the exam, right? Right, so that's part C here, right? That's part C. And we have one more part to this question here, right? One more part here. Find the acceleration of the particle when t is equal to 2, right? When t is equal to 2. So if you know velocity, right? Velocity in this case is minus t squared plus 5t minus 4 minus t squared plus 5t minus 4, right? If I want to get acceleration, acceleration is actually equal to the differential of velocity. So that's dv dt. So this is going to be minus 2t plus 5, right? So that's your formula for your acceleration. And if you want to work out the acceleration when t is equal to 2, all we need to do is to substitute 2 into that formula. So we're going to say that when t is equal to 2, right, a is equal to minus 2 by 2 plus 5. So that's going to be minus 4 plus 5, which is going to give me 1 meters per second squared, right? So you all need to remember, if you have displacement and you differentiate displacement, right, you will get velocity. So if you find ds dt, right, that is equal to velocity. If you differentiate velocity, so if you find dv dt, that is equal to my acceleration, right? And the same holds for if you know acceleration and you want to get velocity, sorry, saying the right thing but writing the wrong thing. Yeah, if you know the acceleration, right, and you want to get velocity, all we need to do is to integrate your acceleration and you're going to get velocity. If you want to get displacement, right, all you need to do is to integrate your velocity and you're going to get your displacement, right? So there's a relationship between differentiation and integration when it comes to displacement, acceleration, and all those things, right? Right, so that takes care of our integration question, right? Now the last question that I have for you guys here is this, right? So you all need to be able to draw a box and whisker plot. You have to be able to draw a stem and leaf diagram, right? So the masses of students in a class to the nearest kilogram are listed in the table below. So we have some masses here. Now I want you to be careful with some of these questions. Sometimes CXC will give us a question and they have not arranged data in ascending order for us, right? For this question here, I think I put it in ascending order already. I believe so. Yeah, I think it looks so. So we want to construct a stem and leaf diagram for this information here, right? So let's take the data, right? Let's take the data across here, right? And I want to construct a stem and leaf diagram. When you're constructing a stem and leaf diagram, right, what you need to do, you need to look at the smallest value and the largest value, right? So in this case here, remember for a stem and leaf diagram, you have a stem, right? And in this case here, we have 30 and we're going up to 62. So therefore 3, 4, 5, and 6, right? So this here will be your leaves, right? Right, so you also need to put a key, right? Just remember to put a key, right? So let's say the first value I'm going to put in the table might be 30. So the key, if I have 30, right, that means 30, right? So when it comes to a stem and leaf, make sure you put in your key on your diagram, right? So you're going to go through all the data and you're going to write it in the stem and leaf diagram here. So the first one is 30, so you're just going to put a 0 here. Then we have a 2, we have a 3, we have a 5, we have a 9, we have a 9, right? So that's the first set of numbers in the 30s here. Then we have 40, then we have 44, we have 45, we have 46, we have 47, and how many 8s we have here? 1, 2, 3, 4 8s, right? So we have 8, 8, 8, 8, that's 4 8s. Right, then we jump to 50, so we have a 0 here. Then we have a 2, we have a 5, we have a 5, we have a 9. Then we jump to 60 now, so we have a 0 here. We have 61, sorry, we have 61, and then we have 62 appearing twice. 62, 62, right? So in this case here, this is our data. But what I normally do, right, I double check. So I have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 columns and you have 3 rows. So that's 24. So just make sure you have 24 in your stem and leaf diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, so I have 24. So this is my stem and leaf diagram here. Right, that's my stem and leaf diagram. All right, so this here represents my stem and leaf diagram, right? State the advantage of using a stem and leaf diagram to illustrate the data, right? So what are the advantages of a stem and leaf diagram? You all need to know that. What are the advantages of a stem and leaf diagram? Right, so I've seen people saying it maintains the original data. That's true. When it comes to a stem and leaf diagram, you maintain the original data, right? So all the data can be seen in a stem and leaf, right? So that can allow us to see, we can see how the data is skewed on that table as well, right? You can see how the data is skewed. Now, the stem and leaf diagram is good for a small data set. You see when the data gets very large, right? We don't want to use a stem and leaf, right? It's very easy to construct. Yes, so I've seen some answers in the chat there. So any valid reason you all give will be fine, right? Any valid reason you give will be fine, right? So I want to know, based on the data, right? Based on the data, what is the mode, right? What is the mode? Let's look at this here. Look at this diagram instead. Could you all tell me what is my mode? Right, lots of people saying 48. Let's see. Now it's easy to identify from the stem and leaf diagram. Yeah, I agree. The mode is 48, right? So that's 48. What is the median though? Look at the data and see what is the median for me. Everybody's saying 23, right? Everybody's saying 23. So one of the things that we have to do, so we want the median, right? So in total, right? In total, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 24, right? You have 24. So you have 24, what it was, students? What did I call it? Yeah, students, right? So you have 24. But the thing is, 24 is an even number, right? So there's no exact middle. So what we're going to do, we're just going to find half of that. That's going to be 12, right? So this is what I normally do. So there is no exact middle, right? But from student 1, right, to student 12, right? That's the first half of your data. Then from student 13, right up to 24, that's your upper end of your data, right? So what I need to do, I need to locate where is the 12th student and where is the 13th student, but I need to know what their masses are. So what you're going to do, you're going to go to the stem and leaf if you want, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case here, it is 8. So the 12th student, right, has a mass of 48. And the 13th student, which is right after, has a mass of 48 as well, right? Right, so in this case, it just happened that your median, right, is going to be 48 plus 48 divided by 2. So you're going to get the same 48 here. So the median happens to be the same as well, right? The next part now, we need to figure out what is the interquartile range. Let's go back to this table here. I want you to look at the data and I want you to figure out for me what is the interquartile range. So interquartile range is simply your Q3 minus Q1. So we need to figure out Q3 and Q1 before we can work this out. I saw somebody mention Dipshan, Mr. Bahal. Mr. Bahal actually taught me A-level maths, right? He's a boss of a teacher. Yeah, he's a boss, right? He's the one who trained me to get a scholarship, right? Yeah. Somebody said man pushing real age. That's probably true. That's probably true. Yeah, so he taught me when I was in Form 6, right? He taught me when I was in Form 6. Right, I've seen a lot of people getting 16. I didn't know you had a son. I didn't know that. All right. All right, let's see what's happening here, right? So you want to work out your upper quartile and lower quartile. Now the thing is, if you look at the data here, you're going to have 12 students on the lower half and you have 12 students on the upper half here, right? So again, that's 12, that's an even number. So your Q1, right, is going to be here. But the thing is, you don't have an exact Q1, right? If I take 12 and I divide it by 2, you're going to get 6. So we need to locate the 6th student and we need to locate the 7th student. We need to get those masses. So if you go to the table here, right, 1, 2, 3, 4, 5, 6. So one of them here will be 9, right, 39 and 40, right? So therefore, that means that Q1, right, is going to be 39 plus 40, right, divided by 2. So this is going to be 39.5, right? So that is what Q1 is. If we go to the upper half as well, that's an even number. You have 12 students there, and you want to work out Q3, right? It means that you're going to be looking for your 18th student. You need to find the 18th student, and you need to find the 19th student, right? So that is, where is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I lost track already, yes? Hold on. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right, so the 18th and the 19th student will be here, right? So that is 50. So Q3, right, is going to be 55 plus 55 all over 2. So that's going to give you 55, right? So in this case here, right, it's going to be 55 minus 39.5, right? So you all got something slightly different there. Right? I'm getting 15.5. Alright, so let's have a look at the last question here, right? Last question I have here, which is a probability question, right? Now there are different kinds of probability questions that CXC can give you guys, right? Now, a lot of the things that help us with probability questions, right? You could be asked to draw a probability tree, right? That's one thing that CXC can give us, right? what we can no, don't round off your interquartile range here. Don't round it off, right? Now, probability. If you are given a probability, you can draw a probability tree. That will help you significantly to answer the question. Also, when it comes to probability, we can draw a Venn diagram if we need to, right? Also, we could draw what we call a sample space diagram. So if you were to roll 2 dice, you could draw a sample space diagram, and that'll help you as well, right? But in this case here, let's have a read of my question here. So Mother's Day just finished, so I set up a question here regarding Mother's Day, right? So when Avasha, right, visits the mall, right, to purchase a present for Mother's Day, she has the choice of purchasing a gold chain or a designer handbag, right? So she go into the mall and she has a choice. She could either purchase a gold chain or she want to purchase a handbag. The probability that she purchases the gold chain is 0.6. If she purchases the gold chain, the probability that her mother likes the gift is 0.7. The probability that she purchases the designer handbag is 0.4. And if she purchases the designer handbag, the probability that her mom likes the gift is 0.8, right? The question is, draw a fully labeled diagram, a tree diagram, to represent the information, right? Now I know it looks like a lot of words here, right? But if you read it carefully, it's very easy to draw the probability tree from this, right? So let's, all right, so this is a question. Right, this is a question. So let's start at this node here, right? So she goes to the mall and she has 2 options. Either it's a gold chain or it's a bag, right? Now the way how I set up the question here is that let's call that C, so that's a chain, and this here is a bag, right? In terms of probabilities, the probability that she purchases the gold chain is 0.6. So therefore, the probability of purchasing the handbag is 0.4, right? So those are 2 scenarios there. Next thing now, if she purchases a chain, the mother could either like it or not like it, right? So you have 2 options here. Either she likes it or she does not like it. So we can write that as L prime. In the case of the handbag, the same options apply here. She can either like it or she does not like it, right? So those are 2 options. Now, let's put in the probabilities for liking. So if she purchases the gold chain, the mother will like it with a probability of 0.7. So therefore, this here is going to be 0.7. So if that's 0.7, the probability that she does not like it is going to be 0.3, right? Just remember, on the branches, when you add it up, you should get 1. So if she purchases the handbag though, right, the mom will like it with a probability of 0.8. So therefore, not liking it should be 0.2, right? So this probability tree is as simple as, just read it carefully and you should be able to produce this, right? Right, now let's see what we're gonna do now. So let me see if you all can answer this. Right, I'm just gonna put a question close to the diagram. So those of you saying you're good at probability here, right? Question says, calculate the probability that her mom likes the gift. Calculate the probability that her mom likes the gift. Let's see what you all can get with this. right? So I've seen a lot of people getting the same answer, right? Which means you all understand how to do a problem like this. So here what? I'm just going to take the 3 and I'm just going to bring it across here. Right, so this is my probability tree here, right? Now we have 2 possible scenarios where she will like the gift. So she can like it here, right? Or she can like it here. So the probability of her liking the gift, right? You can purchase a chain, right? That's 0.6, right? So we can go here and she likes it with 0.7. So that's 0.6 multiplied by 0.7, right? That's one possibility. Or, so when it's an or, we're going to add, right? So the other possibility of her liking it here is if she buys a bag and she likes it. So that's going to be 0.4 multiplied by 0.8, right? In this case here, it's going to be 0.6 multiplied by 0.7 plus brackets 0.4 multiplied by 0.8, right? Yeah, I'm getting 0.74 as well. So you all are correct. The answer is 0.74, right? So well done. Some of you all know what to do, right? Right, next one here, right? Could you all work out the second part for me here? This part. Given that her mom likes the gift, right? Calculate the probability that she purchased the gold chain. Given that her mom likes the gift, calculate the probability that she purchased the gold chain. Right, so I've seen some people saying conditional probability, right? And conditional probability, and you're saying, yeah, that formula is not on the formula sheet, by the way. Conditional probability, right? So let me give you a little help here. So it's a conditional probability, right? So you want to work out the probability. So they said given. Once you see the word given here, that tells us that our sample space has changed, right? And given that a mom likes the gift, so therefore you want to work out the probability that she purchased a gold chain. So that is probability of the chain. I'm calling it C. So the probability chain, given that she likes it, right? So there's a C here. So therefore, in terms of our equation, it is going to be probability of purchasing a chain and liking it all over the probability of liking it, right? So let me make sure I'm not blocking you all here. Hold on. Right. So if she purchases a chain, right, and she likes it, right, that is going to be 0.6 multiplied by 0.7, right? So this is 0.6 multiplied by 0.7, right, divided by the probability that she likes it. So there are 2 scenarios where she likes it. This is what we just worked out, right? The probability that she likes it, we just worked that out. We got 0.74, right? So this is 0.74. So therefore, it is going to be 0.6 multiplied by 0.7 divided by 0.74. And you're going to get 0.57, right? 0.57. I don't know if you all have that. Yeah, some people, I see some people have that, right? Some people got that as the answer. Well done, right? right. All right, guys. So that brings me to the end of my sample paper here, right? That brings us to the end of my sample paper. So I hope that I was able to provide some kind of assistance to you all, right? So please remember to hit like and subscribe to my YouTube channel. So guys, good luck in that exam tomorrow. Read the questions carefully, right? Read the questions carefully. Your biggest challenge, right? Your biggest challenge is going to be time. Time is going to be a problem, right? Time is going to be a problem, right? So try to manage your time wisely. Try to aim for the questions that you are comfortable with first so you can maximize your marks, right? So if you know you're good at statistics, do that first if you want. If you're good at differentiation, go ahead and do that, right? But it's up to you, whichever section that you find to be the easiest, right? Some students like to attempt question 1 first, then they jump to differentiation, but it's what you are comfortable with, right? But manage your time, keep looking at the clock, right? Keep looking at the clock. Also, make sure you work with a proper calculator tomorrow, right? Either you go with the Casio or you go with the Sharp, it doesn't really matter, right? Make sure you know how to use the calculator. All right, guys, so that's it for me for this afternoon. Enjoy. I hope you enjoy the class, and I will see you all sometime. I know some of you all are asking about chemistry and physics. Once I do have time, I will probably do something, right? Once I have time, I'll do something. All right, so just look out for it. Just hit like, subscribe, hit the bell button, all of that drama, right? All right, guys, so take care, everybody. Good night, right? And good luck tomorrow.